I will maximize this question for you. Yeah. So a particle is projected from the ground with an initial speed v at an angle theta with horizontal. The average velocity of the particle between its point of projection and highest point of the trajectory is. So this is again a question from projectile motion. So yeah, let's keep it this way. So a particle is projected from ground at an angle theta. So this, yep. So here is the initial velocity vector u bar, and the average velocity of the particle between its point of projection and highest point. So when it reaches highest point, the velocity is simply u cos theta, and you know when it is at this point, the velocity components are u cos theta and this is u sin theta. So if you want to find out the average velocity, so we can use this. The concept of average velocity is u v bar plus u bar upon 2. This is not for all the cases. This is only when acceleration is constant. Only when a bar is constant. So when a bar is constant, we can actually use this average velocity as v bar plus u bar by 2, which is arithmetic sum of the velocity vectors. So let's try this. So initial velocity vector is this one. So I'm writing it as u bar is equal to u cos theta I cap plus u sin theta into j cap, and the final velocity vector is v bar is equal to only this thing, so which is simply u cos theta into I cap. So you want the average velocity vector v average. Okay, I'll write it this way. So v average is sum of these two vectors, which is you can add these two. U cos theta I plus u cos theta is 2u cos theta I, but there is 2 downstairs, so it becomes u cos theta I cap, and plus u sin theta I j cap plus 0 by 2 will give you u sin theta into j cap divided by 2. So this is the velocity vector. So if you want the magnitude, then you can simply do this one. U is common in these two, so u comes out, and you're left with cos square theta plus sin square theta upon 4, which will also give you u times 4 cos square theta plus sin square theta divided by 4. This is simply u by 2 times of 4 cos square theta plus sin square theta. So you can add sin square to one of the cos squares here, which will become 1, and there are 3 cos square thetas remaining. So this is 1 plus 3 cos square theta times u by 2, which is option C. Yep. So let's move to the question number 14, which is again on projectile motion. The question is, a projectile is thrown at an angle theta such that it is just able to cross a vertical wall at its highest point as shown in the figure. The angle theta at which the projectile is thrown is given by. I don't think it is a difficult question, because at its highest point this is the maximum height, which is h, and root 3h would be half of the range. So maximum height is h and the range half is root 3h. which means the range is actually 2 root 3 h. So let us find out the angle. It is actually, let's divide these two, range and maximum height. So range and maximum height, we're writing it here. So range is 2u square sine theta cos theta upon g, and maximum height is u square sine square theta by 2g. Since I am dividing it, I am writing the reciprocal of that, 2g upon u square sine square theta. So if you divide these two, then you have a general result. So g got cancelled, u square also cancelled. This is 4 upon tan theta. So every time when you divide range and maximum height, then you will end up with this 4 by tan theta, always. So now we'll apply the same thing here. The range is 2 root 3. So I can write 2 root 3 upon height is simply h, which will give you, 2 root 3 h, and height is h. So which will give you 4 by tan theta. So h got cancelled. Then tan theta from this is 4 by 2 root 3, which is actually 2 by root 3. So therefore the angle of projection is tan inverse of 2 upon root 3. Yeah. Move on to the next one. And this is a question on pseudo force as well as the normal force, like laws of motion. On the floor of an elevator, a block of mass 50 kg is placed on which another block of mass 20 kg is also placed. The elevator is moving up with constant acceleration 1.5 meter per second square. So elevator is moving up with a naught is equal to 1.5 meter per second square. Then the pseudo force on everything will act in downward direction, which is ma naught. Force exerted by 20 kg block on 50 kg block is nearly. So 20 kg exerts force on 50 kg. This is what we are supposed to find. So how do we do that? We'll draw the free body diagram. Then we'll know the answer. The force exerted by 20 kg on 50 kg. So I'll draw the free body diagram of 20 kg block. This is 20 kg. So gravitational force is in downward direction, which is 20 g. Normal force given by, force exerted by 20 on 50 is same as 50 on 20, because this normal given by 20 on 50 is same as normal given by 50 on 20. So if you can find out either, they are still same. So but the directions are different. So this is the normal given by 50 on 20, which I am writing it as n1. So we are supposed to find n1. Apart from this, since this whole system is also moving upwards with acceleration 1.5, then the acceleration of the pseudo force it on it is ma naught, which is 20 times of 1.5. So since it is at rest with respect to an observer in the elevator, so net force is like n1 is equal to 20 g plus 20 into 1.5. Since the answers all is like round figure like 0 at the end, so we can take g equal to 10. Otherwise I would have taken 9.8. However, it is not mentioned in the question. So because if it is not mentioned, you are supposed to take 9.8, right? But here the answers are in round figure. So we'll do something here. So g is 10. So this is 200 plus 20 into 1.5 is 30. So the answer is 230. Yeah. So g is like nearly is what is mentioned here. So that is like g, take g equal to 10. That's what the questioner says. So 230 Newton is the force exerted by 50 on 20. But you are asked to find 20 on 50, which is same. So this is 230 is the answer for this question. Next, a block of mass m is placed on a frictionless inclined plane of inclination theta with horizontal. The inclined plane is accelerated horizontally so that the block does not slide down. In this situation, the vertical force exerted by the inclined plane is. Oh, this is simple. First, we'll draw the inclined plane. So here is the inclined plane. A block of mass m is placed on a frictionless inclined plane with the horizontal angle theta. The inclined plane is accelerated horizontally, so obviously that it has to be accelerated this way, so that with acceleration a naught, so that the pseudo force acts on it in the other way and it can keep it in equilibrium. So let's write the forces acting on it. This is ma naught, so this would become ma naught cos theta, and this is ma naught sin theta. The normal force is this, and this is mg sin theta, and in this direction there is also mg cos theta. So if the block is at rest with respect to the inclined plane, so the simple that this and this has to be same, which are along that inclined plane. So you can write ma naught cos theta is equal to mg sin theta, which will give you a naught is equal to g tan theta. Now if you observe the normal in normal direction, like if you take this is y axis and this as x axis, then along y axis sigma fy is equal to 0. So you can write n is equal to mg cos theta plus ma naught sin theta. But we know a naught is tan theta, so we can substitute that here. Then you have mg cos theta plus m into a naught is g into tan theta. Tan theta can be written as tan theta into sin theta. So you can take mg common. So what is left here is tan theta can be written as sin theta upon cos theta. So this is cos theta plus tan is sin upon cos, so you have sin square theta divided by cos theta. So the cos comes here, cos square theta plus sin square theta is 1, so you are left with n is equal to mg by cos theta. So this is what is, but that is asked the vertical force exerted by the inclined plane. So n is a normal force, but that's not vertical. So if you make two components like n cos theta is mg, so now if you observe this is n, so I'm making the components of n. You can see here n is in this direction, so this would be, this is theta, so this is n cos theta. I'll change the color here. This is n cos theta and this is n sin theta. So you are asked this one n cos theta, and the value of n cos theta is mg, so the answer is simply mg. But the other way of understanding the question is simple. See, the block, apart from this pseudo force, there is also gravitational force acting on the block, which is in downward direction mg. In order to keep the block in equilibrium, you also have to apply a vertical force of mg in upward direction, which is n cos theta, and the other n sin theta is balancing actually the pseudo force. So therefore, In simple terms, if you read the question clearly, the inclined plane, if accelerated horizontally, the vertical force exerted by inclined plane has to be mg, because when mg is downwards, if you apply same mg upwards, it will be at rest in along vertical. Forget about horizontal, only vertical is concerned. So that should be n cos theta, which is the answer. And here comes a good question, 17th question. In figure, two identical particles, each of mass m, are tied, it's wrongly misprinted here as tried, together with an inextensible string. This is pulled at its center with a constant force. If the whole system lies on a smooth horizontal plane, then the acceleration of each particle is. Okay, so this is a particle of mass m here and the other particle of mass m here. So tension always tries to pull the mass, so this is T, and again this is T, and here also this is T, and this is T here. So I think this is like, if this is T and this is T cos 30 degrees, and also for this T, this is, so this is like whole 2T cos 30 degrees. So I can write, here I'm writing it here, 2T cos 30 degrees is equal to F. So cos 30 is root 3 by 2. So T root 3 is actually F. So from this you can write T equal to F upon root 3. Now this particle which is here is being pulled in this direction with T. So it would move with acceleration in this direction as well as in this direction. So since this is D and also this angle is 30, so this is T cos 30 degrees and this is T sin 30 degrees. So let's try to understand this question perfectly. That if the whole system lies on a smooth plane, the acceleration of each particle towards each other. So since this particle has acceleration in this direction and also in this direction as well, and also this particle has acceleration this way and this way, but these two accelerations are not towards each other. However, these two accelerations are towards each other. So we are interested in only finding this component of acceleration, which is due to T sin 30. So I can write T sin 30 is equal to m into acceleration of particle towards each other. So TE, like towards each other. So T into T is like F by root 3 and sin 30 is 1 by 2 is equal to m into acceleration towards each other. So the acceleration of particle towards each other should be 1 upon F upon 2 root 3 m. That's it. Which is option 2. This one. Yep. Let's move on to question number 18. What force must man exert on rope to keep the platform in equilibrium, and G is taken as 10. There is no complication in this question. This is simply, if you draw a free body diagram, you will get the answer. But before drawing free body diagram, let's maximize this, and directions of tension here. This is a T, so this is a T, and again this is a T. So this has to be 2T. Yeah. Right. I think this is good. Yeah. So let's draw the free body diagrams of man as well as platform. So for platform, we'll draw the free body diagram. Platform is 40 kg, so 4g downward. Man exerts normal force on the platform, which is N, and 2T is in upward direction on the platform. And also for man, I'm drawing the free body diagram of man. The weight of the man is 50 kg, so I think this is, sorry, 4G or 40G. 40G. This is 50G, and tension on the man is T upward direction, and platform exerts normal force on the man in upward direction. So what force must man exert on rope? So the T is asked. So we can find out T by eliminating N. So let's see how we do this. Here in equilibrium we can write 2T is equal to N plus 40G, and here we can write for this T plus N is equal to 50G. Okay, let's say this is expression 1 and this is expression 2. I think if we simply add these two, we'll get the answer, I think. Yeah. So we'll add these two expressions, 1 and 2. So first expression is 2T is equal to N plus 40G, and the other is T plus N is equal to 50G. So if you add these two, you got 2T plus T is 3T plus N is equal to N plus 90G. So N got cancelled and T is equal to 30G. So I think that is what is required here. So tension T is equal to 30 into G, which is 300 Newton, which is the answer for this question. Where is that? Yeah, here. So what force must man exert on rope to keep the platform in equilibrium, which is tension? But also if you want to find out the normal reaction, you can simply substitute this here. That will give you N is equal to 50G minus T, which is 500 minus 300, which is simply 200 Newton. Yep. Let's take a look at next question, which is question number 19. A body of mass 2 kg is moving along positive x-axis, x direction with a velocity of 5 meter per second. So 5 I cap is initial velocity. U bar is equal to. Now a force of 10 root 2 Newton is applied at an angle 45 with x-axis. So (10√2 Newton) making an angle 45 degrees with x-axis. So that force has to be F bar is equal to 10√2 cos 45 into I cap plus 10√2 sin 45 degrees into J cap. I am writing it in vector form. So this is simply 10 I cap plus 10 J cap, which is the force vector, which can also be written as M into A bar. So the acceleration vector is by M. M is 2, which is mentioned here. So the acceleration is 5I plus 5J. Now the velocity after 3 seconds is, so V bar is equal to U bar plus A bar into T. So U bar is 5 I cap. We can simply use this because acceleration is constant, plus A bar is 5 I cap plus 5 J cap times T is 3 seconds, so write 3. So now you have 5 3s 15I plus 5I is 20I cap plus 5 3 is 15 J cap. This is the velocity vector after 3 seconds. But it is not asked in vector form. We will find out the magnitude, which is root over simply 20 square, which is 400, and 15 square, which is 225. 400 plus 225 is 625, and root 625 is simply 25 meter per second, which is the answer for this question, option 3. Let's move on to question number 20. A body of mass 3 kg is moving along a straight line with velocity of 24 meter per second. When it is at a point P, here is an interesting question. That's yeah. Yep. So a body of mass 3 kg is moving along a straight line with the velocity of 20 meter per second. When it is at point P, I don't know where is that point, so we'll mark it here somewhere. This is point P. This is moving with 24 meter per second. Let's assume it is moving in positive x direction. When it is at point P, a force of 9 Newton acts in the body in direction opposite to the direction of motion. So here a force acts in this way, F. We don't know what is at F. The time after which it will be at P again. See what happens when you apply force in this direction. The particle actually retards, so it goes this way. The velocity of the particle will become 0 somewhere, and again it will accelerate in backward direction and it will reach point P. And what you have to realize is when it goes to that particular point where velocity becomes 0 and again it comes back, it will have a velocity equal to this velocity 24 but in the opposite direction. So we can find it simply using this. We'll use it after time. Yeah, so we'll use V bar is equal to U bar plus A bar into T. So V bar is final velocity which is in this direction. It will be again 24 meter per second. So I'm writing it as minus 24 is equal to U bar is plus 24. Acceleration is simple. F is equal to ma. The force acting on it is 9 Newton and mass is 3 kg and acceleration a. So a equal to 3 meter per second square, but is in the opposite direction. So write it as minus 3 into t. So we can solve this. Minus t, 3t comes the other side, becomes 3t. 24 plus 24 is 48. So t is equal to 16, 3 is 48. So the answer is 16 seconds, which is option 2. So I hope you understood this one when it comes to point P. The other way of doing this is also like we can apply S is equal to ut plus half at square. Since it reaches the same point, S is 0 because displacement is 0. So we'll use this formula and solve it once again. So S is 0, so 0 is equal to initial velocity is 24, so 24t. Retardation is a, which is again minus 3, so minus 1 by 2 into 3t square. So however in this also you will get the same answer. So you can write this as 3t square upon 2 is equal to 24t. T got cancelled, then you have t is equal to 16 seconds. So both will feed you the same answer, but this is what is you have to understand, that when the retarding force is acting on it, the velocity becomes 0. Again it will come back, will have a same velocity. That is what is required here. Otherwise this is simply solved using S equal to ut plus half at square, where it reaches point P again, so displacement becomes 0. Yep. The other question, a body starts from origin and moves along the x-axis such that the velocity at any instant is given by, so V is given as 4t cube minus 2t, where t is in second and velocity is in meter per second. What is the acceleration of the particle when it is 2 meter from origin? Okay, fine. So when it is 2 meter from origin, it is also given that the body starts from origin. So first we'll find out acceleration, which is a derivative of this one, dv by dt. So d by dt of velocity, which is 4t cube minus 2t. However, you all know this that the derivative of t cube is 3t square, so which will give you 12t square minus 2 is the acceleration. So the expression for acceleration is 12t square minus 2. So we are supposed to find the acceleration, but time is mentioned here. Here the when it is 2 meter from origin, so we don't know when it is 2 meter from origin. So for that we also have to integrate v, because dx by dt is v and dx is integral v dt. So we'll integrate on both sides, but before integrating, starts from origin, so like v is 0 when x is 0 and v is v when x is x. So then you have x is equal to integration of v dt is, wait a second, this is t. So this is integrate, let's integrate this one. You have 4t cube integral 4t cube minus 2t dt. So on integrating it, you have integration of t cube is t power 4 upon 4. So 4 got cancelled, then you have t power 4 minus integration of 2t is simply t square, because derivative of t square is 2t. This is the position of that. So what is the acceleration of the particle when it is 2 meter from origin, which is like x is equal to 2. So let's substitute x equal to 2 here. When x is 2, so you have 2 is equal to t power 4 minus t square. So this can actually be solved by taking t square is equal to some L, and you can solve it. But if you simply observe this equation, then if I simply put t square is equal to 2, it satisfied this. Try to understand this point, that if I substitute t square equal to 2 here, then this would be 2, and this is actually the square of t square, which is 4. 4 minus 2 hence will give you 2. So what you have to understand here is t square is 2. See, to make the answer simple, this is what I observed from the expression, that instead of solving it, if I simply put t square as 2, because 2 square is 4, so 4 minus 2 is 2. So I can understand just by seeing it, and I also want you to understand this, that t power 4 will be 2 square, which is 4. 4 minus 2 will give you 2. So hence, instead of finding the value of t, which is of no use because anyhow I have to substitute t square here, so t square is simply 2. So then the acceleration would become 12 times of t square, which is 2 and minus 2, which will give you 24 minus 2 is 22 meter per second, which is the answer for this question. Now you have one more question here, 22nd one. Two particles are moving with velocity v1 bar is equal to I cap minus 2t j cap meter per second, and v2 bar is equal to 4 I cap plus j cap meter per second respectively. The time at which they are moving perpendicular to each other. This is very simple question. When two vectors are perpendicular, then the dot product becomes 0. First I'll equate the dot product of them to 0. Then you have dot product is simply multiplying the coefficients of I and adding them, and also coefficients of j and simply adding them. So you have 1 into 4, which is 4, minus 2t into 1, which is 2t, is equal to 0. So therefore 2t is 4 and the value of t is 2 seconds. So at t equal to 2 seconds, they are perpendicular to each other. That's the answer for this question. And yep. So there are three questions remaining, 23, 24 and 25. I want you to try it by yourself. You can simply pause the video and note down the question and try it yourself. If not, I'll post the solutions for these questions in my next short video somewhere. Yeah, that's it. Thank you.